Hey everyone! Today I am going to be talking about how planetary motion works today and why it was talked about. What is planetary motion, you might ask? Planetary motion, in simple words, is how the planets move in a circular motion known as ellipsis, which orbits the sun as the focus. So when you think of this, you would probably think that the Earth would just come crashing forward the entire universe. But because of Newton's law of motion and gravity, there is a constant pull which bends the way the Earth is rotating. Today, planetary motion is being used to launch satellites into space to see how they are moving. Planetary motion also helps us today by changing the sunlight direction, which helps the climate changes, which can then turn into all kinds of new sediment being spread around. Now, you might be asking who came up with such a term called planetary motion. It was Johannes Kepler. He was a German astronomer as well as a mathematician. He came up with 3 different laws of planetary motion. His first law states that how planets move in elliptical orbits with the sun as a focus. The second law is where a planet covers the same amount of space in the same amount of time, no matter where the orbit is. And the last law is how a planet's orbital period is proportional to the size of its orbit. At first, his discoveries were not approved by the churches or people at the time, but they eventually came to the idea of his. I know what I just said could have 1,000 different meanings, so here is an in-depth video on how you could visualize these laws being set into place.
First law. The orbit of a planet is an ellipse with the sun at one of the 2 focal points. Second law. A line segment joining a planet and the sun sweeps out equal areas during equal intervals of time. Third law. The square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. That is, p square is proportional to a cube.
If I were to put a line graph in here, you would see a lot of formula-skilled ideas being thrown. So in this so-called graph, you can see how fast each planet rotates or spins. The semi-major axis on the bottom shows us the distance from the center of the ellipse to its furthest edge point. So, for example, Mercury is spinning extremely fast, but it does not really move as fast as it rotates. But if we were to look at Pluto, it's not really spinning that fast at all, but it is moving in a counterclockwise direction extremely fast. Okay, so now since I've done all this talking about how planetary motion works and all this stuff, I'm going to be giving a demonstration. So what you need is you need a pen, you need a piece of string like a yarn thing, and I have 2 thumbtacks and just a piece of paper and like cardboard behind it because it wouldn't go through. So I'm going to get a better angle on this and I'm going to show you how to do an ellipsis. The thumbtacks represent foci. The horizontal line is the major axis and the vertical line is the minor axis. So I'm not going at a fast pace because obviously this is homemade. With the pen pulling the string, it is making a complete circle, which was said to do by Kepler. This mainly has to do with the first law. In this second demonstration, I have moved one of my thumbtacks down, and as you can see, it is starting to make a different circle, which represents another planet making the same orbit around the sun, which is still the main focus. In this last demonstration, I have moved the white thumbtack back to the original place, but further away from the blue thumbtack. No matter how far away a planet is from the sun, it still takes the same circular path to get around. So after doing much more research, I now understand what planetary motion is exactly about. Kepler's laws of planetary motion are represented within this project. I hope I conveyed it to y'all so that y'all have a better understanding of planetary motion. Thank you for watching and letting me explain to you the process of planetary motion.